slips over the top. That's a 1/2 inch reamed hole. Welcome back to Workshop Friend and part 2 of fitting this collet chuck to my Colchester Student lathe. Last video we made the bracket which sits on the headstock, and in this video we're going to make the link and the hinges. So now the bracket is completed, the bracket which bolts onto the headstock. It's time to work on the other end of the assembly. So there'll be a hinge formed here, and the handle will be at an angle something like that when it's all assembled. And what I'm looking for is a nice positive action without a lot of slop. So that's why I'm paying some attention to the design of the hinge. Now I'm going to use a 5/16 UNF bolt, and that will pass through here. There'll be a washer here to provide a nice location on this bore, and a captive nut on the other side here which will be Loctited in place. Now between the two there needs to be a spacer, and the width of that spacer is going to be determined by the compressed state of this. So when this is brought together, once these sides are parallel, that's the space I want. So I've measured that, and that's determining the width of that spacer. Now in addition to that, we need a couple of washers. So the strap, which is made from 1/4 inch material like this, although not as wide as that, comes in here. So the spacer has an inbuilt washer on this side, and there'll be a loose washer for assembly on the other side, which should just bring enough space in the middle there to hold the strap. Now although this sounds rather complicated, it actually only requires 4 components apart from the bolt itself and the strap. So we've got the spacer here with its inbuilt washer, we've got the loose washer for assembly on the other side, we've got the captive nut here with the 5/16 UNF thread, and we've got a washer on the other side here. So I'm just already working on that on the other lathe. So I'm working on the captive nut now. Basically this is machined, and I've drilled it out for tapping, but I didn't have exactly the right size drill, and it was about 1/7 thou undersize. So rather than force the tap through, I thought I would just run through with this mini boring tool and just open it out slightly. We just need about 7 to 10 thou extra on the diameter, and that would just make tapping that little bit easier. That should help with tapping. So I've just reversed the work in my 4-jaw chuck, ready for facing and a final chamfer. I'm now starting to work on the link, which is made from a piece of 1/4 inch bright drawn mild steel bar. I didn't have the right width, so I cut this down from a larger piece, and I'm using the shaper to bring it to 7/8 of an inch width. So we're looking for 0.875, and we are 0.885, so that's 10th to come off. That's 1/4 millimeter. This is a metric dial on here. I've taken a little time out to make a jig for my small rotary table so that I can easily radius items which have a concentric hole on the end, and of course that's what I need to do for the link. And I mean, I could have just done this by marking it out and filing it, and to be honest with you, that would have been quite quick. This is the kind of operation that comes up often, so why not make a little jig? So I've got this piece of plate, I bored it and I've Loctited it to shaft. The other side will locate in the center of my rotary table, and I'll put a thread on here, and that will enable me to hold one end of the component I'm machining. You'll see that later. So I'm just finishing machining this off. It's a couple of hours out of the other job, but I think it's probably going to be worth it in the long run anyway. Just lining the tool up by eye before turning on, just to make sure that I don't have a dig in. The Myford Super 7 headstock has a tapered bronze bush and two angular contact ball bearings towards the rear. And you can see here that with tailstock pressure it's caused a slight lockup, and this is an adjustment problem. I've tried several times to get this right, but just haven't succeeded so far. Great for marting, but tailstock pressure causes a problem. Adding a generous chamfer to the top side. I'm taking extra care to ensure that all surfaces are square with the axis of the part I'm making. So for that reason I have to use these rather extended tools to get right into the back and to ensure that all sides are machined in the same setting. So returning now to actually making the link, I've got it on the horizontal mill and I'm just picking up the edge with the feeler gauge, and then I'm going to traverse across using my clock on the magnetic base there, and the whole purpose is to pick up the center line. Now my mill doesn't have much height because it's a horizontal mill, so I use this just to center drill, and then the rest of the operations will be done on my pillar drill. I've already gone ahead and put in one of the holes in here, that's 1/2 inch reamed hole, and what I want to do is to produce a nice radius like this. Now I could have done that by hand, but this is an operation that comes up quite often, so I thought I'd make a little fixture to enable me to not only do this job but future jobs. So this is my homemade 4-inch rotary table, and you may have seen me use this on videos before. So what I've made is this little fixture here, which locates accurately in the bore there. That's a 3/8 reamed hole, and I've got a nice snug fit in there, and that comes in over the top. And then on top of that we've got a 1/2 inch shaft. As you saw, I machined this all in one setting, so this and this are concentric, and these faces are also square with the axis. So that goes on there, and so in operation the first thing I do is set this up on the mill directly under the head. So I'll clock that in with my clock, and these little T nuts come in, and that sits over the top like that. And I've recessed these. It looks a little bit complicated, but the reason that I have done this is to save vertical height, because I'm using my horizontal milling machine to do these operations, and it doesn't have a lot of height, so anything I can do to save height is helpful. So by recessing this, I can keep the heads of the nuts down. And then there is this bar that slips over the top. That's a 1/2 inch reamed hole. That sits over here, like that. The work I want to radius goes over here, like that, and then there's a nut and a bolt. So what that does, it ensures that I've picked up the center of this. So this is milled so that it sits both on here and on the rotary table, just to provide a bit more support for the work. And this comes in here like this. I think for some jobs this wouldn't be necessary, but probably today it is. And then that just provides a bit of extra support so that we can ensure the work doesn't move, like that. This is recessed underneath here, so we've got sufficient height for the milling cutter to come in. Let me go and get the milling cutter. The milling cutter can come in underneath the work, but over the top of the head, and clear everything else. And we can go from here to here. We've got sufficient space to do that without any other clamping features getting in the way. And that's nice and rigid, and that will help me to finish this work off. You're probably thinking to yourself, that's an awful lot of work to go to just to radius 2 ends of this strap, but I'm thinking ahead, and this is the kind of operation that you have to do, or I find myself doing repeatedly, so I thought it was worth taking time out to make this. I've tried to do it without, and it's not easy actually, so this setup will definitely save time in the future. So I'm going to go over to the mill now, and I've already centered this. I'm going to drill this out to just under 1/2 inch and then ream that 1/2 inch, so I've got the 2 holes for a location on the jig, and the final operation of this is to radius 2 ends. As you can see, I'm taking some care to ensure that this fine drill picks up the center drill hole correctly. As I progressively open up the hole with larger drills, I'm assuming that each drill follows the previous one, and hopefully we'll end up with a 1/2 inch hole on the original center line. It's time to profile the 2 ends now, so at last I can use this setup. There's one slight problem, that despite my best efforts, the holes are not bang on center. This one, which is not too bad, that's about 2 or 3 thou off center, but this one is a lot more. So this one's around about 8 or 9 thou off center line. We'll start with the worst one, and what I'll do is I won't try and follow the 2 sides. I'll follow the hole, so the radius will be according to the center line of the hole, and it means one side it's going to be a nice tangent, the other side it's not. Anyway, that's just the way it is. So we'll set this up first, do the worst one, and then do the better one afterwards. I forgot. Got to set this up on the mill first. Here I'm just picking up the center of the rotary table and ensuring it's in line with the axis of the mill. It should be possible, even with my restricted height, to pick up the center of the fixture without really removing it each time, but I'm yet to try that out. So at last I get to try out the new fixture and radius the two ends of the link. And it really didn't take too long at all to complete both these operations. Just adding the extra clamp for extra security, make sure that things don't move. Again, I'm using the feeler gauge to pick up the edge of the work. I will set the dial at 0 on the edge and then move away from the work and then progressively move inwards, and when I reach 0 I know I've completed the radius. Initially I was cautious on the climb milling, where the direction of the cutter and the work in the same direction. I was afraid that it might grab, but actually even with my small rotary table it was quite capable of handling that. As you can see, I knocked the corners off to save time in this profiling operation. One other observation, I probably would disengage the worm drive next time and use a Tommy bar so that I don't unnecessarily wear out the mechanism. After all, it is a rotary table and I would like to use it for indexing, not just for milling.